Okay, so we're looking at 9-3 bar graphs and dot plots. You should recognize this. I think y'all seen these before. Everybody seemed to kind of understand them in the last few classes. We're going to talk specifically about bar graphs. So bar graphs are going to break down things individually. So like this is the favorite ice cream, and then they broke it down individually. Like, for example, they said that 24 people liked vanilla ice cream, and that's how you read that bar graph. One of the other things we're going to talk about is dot plots. Okay? The key thing to this is making sure you read, if there's a legend and it says that that dot represents more than something else, you need to make sure you read that, because that can confuse you and get you the wrong answer sometimes. So a bar graph is a type of graph that shows the number of items in a specific category. A dot plot is a graph that shows the frequency of a set of data with a number line. Okay? So both types of these graphs can be used to make a part to whole comparison. So both of these graphs are making a part to a whole. So like, for example, if you add up all of the different amounts of ice creams right there, it's going to add up to 100 total. Okay? So they do that right here. They add it all up and it came out to 100. So they're asking specifically to use the bar graph to compare the total number of people surveyed to the ones who chose berry. Okay. They did it a little differently than I would have done it on the example. I would have said, okay, well, 16 people chose berry. 16 out of 100 is what percent? And so they went ahead and divided it and got 6.25, which is kind of different. So 6.25 times as many people were surveyed than chose berry. So I would have made a comparison. I would have said, well, if 16 chose berry, then 84 didn't. How do you relate 84 and 16? Does that make sense? That's how I would have done it. But that's how they did it for on this page. Example 2. The dot plot shows a number of free throws made by members on a basketball team during their last game. What fraction of the total number of players made 2 or less free throws? Okay, 2 or less is going to have some big meaning right there. Does that include 2? Yes. So it's going to include 2, so it's going to include all of this right here. So 1, 2, 3, 4, 5. So 5 of the players made 2 or less free throws. So 5 out of 10 players. So half of the players made 2 or less free throws. Okay, so they got 10 by adding up the 5 here and then these 5 right here. That's a total of 10 players that happens. Do y'all see where they're getting that information from? Okay. It says use the bar graph from example 1 to compare the number of people who chose vanilla to the number of people who chose strawberry. So we're going to go with vanilla first. So vanilla is 24 out of 100. And then I'm going to figure out strawberry. Strawberry is 12 100. So what can we say? How can we compare those two? What's happening? What's 12 to 24? Not divided by 2. Half the people chose strawberry, then chose, so twice as many chose vanilla as they did strawberry. We can say all of that wording. So we could go with twice as many chose vanilla than strawberry, or half chose strawberry than vanilla. There's a lot of ways you can go with that wording. Number 2, the dot plot shows the number of times per week that a group of students use a fitness center. How many more students use a fitness center 3 or more times a week, so it includes 3, then 2 times per week, okay? So, then less than 2 times, I'm sorry, that wording. So we have 3 or more is 4, 8, 11 out of 12, 13, 14, 15, 16. Compared, we're going to say less than 2 times a week, so that's not going to include those right there. So it's going to be compared to 2 out of 16. Okay, so how many more? What does how many more mean in our word? Subtract. So we would say 11 minus 2, which is 9. So 9 more students used it 3 or more times a week than they did less than 2 times a week. Okay, looking on your back page, the bar graph shows the number of pets the students in Mr. Murphy's class own. What fraction of the total number of students owns 1 pet? Okay, so we're looking at just this column right here, which is 10 own 1 pet. Out of 10 plus 6, 16, plus 5 is 21, 22, 23, 24. So 10 out of 24 students own 1 pet. And so we're going to express it in simplest forms would be to reduce that fraction. Yes, sir.
Would it be 5 or 12?
Yes, sir. 5 times. Okay. Number 4, compare the number of students that own no pets to the students that own a number of 3 pets. So no pets is 6 out of 24, and 3 pets is 2 out of 24. So if you compare it, there's more people that own no pets than own 2 pets. Okay? Are you with me there? Okay? I'm going to write that right here.
And then would you subtract 6 minus 2?
Well, it's not saying subtract here. It's just saying compare. So we're just using words to compare.
Where are we writing that?
There is more people that own 0 pets. I'm sorry. So you just write anywhere on near that part.
Well, I zoomed in and I can't see where we're writing it.
On number 4.
Dang it, I wasn't on number 4.
Okay. Number 5. What fraction of the total number of student owns more than 2 pets? Okay, so more than 2 does not include 2, so it would include this group right here and this group right here, which is 3 out of 24, and then they want it in simplest form. So what's it going to be?
3 over 4.
1 over 8. Okay. And then number 6, compare the total number of students to the number of students owning 2 pets. Okay, so comparing total number of students is 24 to the number of students owning 2 pets. So 24 to 5, we can compare it that way. Everybody see kind of where we're getting that? Okay, the dot plot shows the number of computers, both desktop and laptop, that family use. What fractions of the family use 1 computer? Express it in simplest form. Okay, so 1 computer would just be this right here. So this would be 3 out of 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3 out of 13 families. So what we want, we're back to what we want out of total probability. What fractions of the family uses either 2 or 3 computers? What would you get there? 2 or 3 computers.
It would be a whole 2.
No, we're 2 or 3. So how many is that? 8 out of how many total? 13. Compare the number of families that use 2 computers to the number of families that own either 0 or 4. And 2 computers is 4 to the number that owns 0 or 4, which is 2. So it's actually just asking us to compare, so we can write that as a ratio. And then number 10, compare the total number of families to the total number of families that use less than 2 computers. So we would say 13 to 4. Because we would count this group right here because it's less than 2. Less than 2 does not include 2. We need to remember those words. And then number 11, what fraction of the family use at least 2 computers? Express it in similar. So at least 2. So this is this one, and this one. So it'd be 9 out of 13. Can that be reduced? No. Okay.